On May 14th, the Dark Energy Spectroscopic instrument, DESI, has started regular operations. Michael Levi, you're the director of DESI. Julien, you're DESI project scientist. First of all, congratulations, and thank you for joining us.
Thank you.
Can you explain what happened a few nights ago, the significance of that?
Well, after many years of construction, we started our main scientific survey. And this survey will map the universe out to about 11 billion years from now in a huge three-dimensional map of the sky. And it'll collect the data that our 200 graduate students are waiting. So they're very excited to finally be getting data. And we're, of course, just coming out of a pandemic. So getting this 5-year survey rolling finally is a very big moment for the collaboration. So we're incredibly excited for this transition to happen.
Well, on Friday night, we started observing. So it's going to go for 5 years, which is really amazing. This was the goal of all of the project construction. We're going to map 1/3 of the sky, which is basically all what we can see from the telescope in Arizona if you avoid the galaxy. We're going to do a redshift survey of about 30 million galaxies. So this is a massive project. It's really the stage 4 experiment for the measurement of dark energy. It comes after earlier projects like BOSS and eBOSS.
And what did it take to get to that point?
Well, we needed a lot of very dedicated individuals to get us running again. We shut down in March of last year for because of the pandemic. We took a pause. Around September, we started recommissioning the instrument, getting the telescope running again, making sure that we could get on sky, take data in a regular fashion. And so it was a lot of work, difficult work under pandemic rules, making sure that all the staff were safe. So that was a big process to just get to this point. And now we can run in a normal mode. And of course, we can do remote operations as well that we've developed during this time period. So we're running well, and we're very excited now to be taking this data.
You've mentioned the pandemic. I'm sure this put a huge kink in the plans. So how was it adapting to that and leading, an entire collaboration through these changes?
Of course, everyone was working from home, and we're all on Zoom. So it's a very different environment to be sitting at home and your experiment is up on a mountaintop thousands of miles away from you. So this is a difficult work environment to get everybody, working together with this sort of common goal of getting the experiment back on sky. So that was quite a challenge. But everyone worked, well together, and everyone's very excited. So we're pleased to be at this point.
And so even though now less people are allowed on Kitt Peak National Observatory, which is where DESI is installed, have you been able to spend much time at the observatory yourself?
Well, I've not been back there during the pandemic, but certainly during commissioning and during installation, I was camped out there during installation. And it's a beautiful location. I love it. It's the high desert. When I was a teenager, I actually spent summers out there. So I just have a real affinity to the place. I think it's just gorgeous. And of course, during installation and commissioning, it was a lot of fun to be there. So it was every day there was something new happening and new coming in, and it was very fulfilling to watch it come together. So yes, of course, I'd wish I could spend more time together, out there. But I'm not needed at this point now that we're running.
So you mentioned commissioning. You've mentioned installation. I understand the project took about 10 years to get together. Is it coming together quickly or slowly for comparable cosmological projects?
Well, this is a 10-year. This project started 10 years ago in 2009. That was the inception. In other words, have a great idea. Well, having a great idea while you're sitting in your office doesn't lead to a construction project. You have to then go convince your colleagues that this is a good idea. We would take it to various national committees, convince the government that they wanted to fund it. We got private, also grants from various science foundations. That was a 5-year process to get to that point. where we were finally constructing, and then it took 4.5 years to actually build it. That's actually quite a rapid construction cycle. So 4.5 years. A lot of projects take a lot longer than that. So it seems like it was quite fast, in fact.
Now, I also understand that different pieces of DESI were built simultaneously, but in different parts of the world. That's very efficient, but also brings a particular set of challenges.
Well, of course, we like having all our colleagues all over the world. They all have these great specialties. And so we had different organizations building different components of DESI all over the planet, which does lead to a challenge, and that was bringing all that equipment back to the United States and installing it up at Kitt Peak in Tucson. We had a lot of shipping. I had to learn much more about shipping than I ever wanted to know. We spent a lot of money on shipping. And things come in and they get damaged in shipping. We had actually a piece of equipment stolen off the back of a truck. We had components that were, they were well protected in their crates, but the crates did not survive shipment. So it's a little, it's a little scary when the wooden crate shows up and there are 2x4s that are broken on it, or there's a hole in the side. So when we finally got to the end of the project and we had our big corrector, which had these 6 enormous lenses, 3-4 feet in diameter, and expensive. It's like $10 million worth of equipment sitting in London, and we're trying to figure out, well, how are we going to get them to the top of the mountain? And so we chartered an airplane instead of risking sending it through who knows what ports of call in the United States. And so it came in on a Russian troop transport. So that was a lot of fun.
Julien, we're going to do, as you mentioned, 1/3 of the sky and do a 3D map from this. Now we're running for 5 years. Is the work done, or what is left to be done?
So that's really just the beginning. We are collecting a huge amount of data every night. We are collecting about 50,000 redshifts every night. The best night we got, I think, 70,000 or even more. So we have to process all of this data real time, and we have at the same time the whole collaboration that is looking at this data set. So what the collaboration is going to do first is produce a redshift catalog out of this data and measure very accurately the efficiency of this process in order to correct for it when you are interpreting the data.
Okay, you mentioned, did I get that 70,000 per night? Are you breaking world records right now, or?
Yeah, definitely. Everybody is really amazed by the pace at which the survey is going. During the survey validation period that we just ended, we collected more than 1 million redshift, which is comparable to all of the previous surveys.
How long did survey validation last?
That was just a few months that we started in end of November or December after recommissioning a period and after this long break we had because of the pandemic.
So just a few months, and other cosmological surveys have lasted for years. So DESI in a few months is doing what others have done for years. Is that correct?
Exactly. So that's thanks to really the design of the instrument, which is massively parallel. We have 5,000 fibers. That's really 5 times more than the previous projects. We have a larger telescope, so we can acquire the amount of signal we need much more rapidly. We are repositioning automatically our fibers. This is a huge gain of time. You have to think that between 2 exposures, we only lose two minutes to reposition the whole instrument.
Compared to 2 hours before?
So before, for BOSS, you had to, for the BOSS experiment, there was no robots, and you had to actually drill plates in aluminum and then move around those plates on tray and plug them in the telescope, which was taking, of course, a lot of time.
So that sounds like a very complicated instrument. Do you have any favorite piece of technology in there, or?
So DESI is immensely complex, and it's a miracle that we are here today and able to run the survey. I've followed it. I was lucky to follow it right from the beginning, and it's been really amazing, the different components put together. Just citing a little bit, I mean, the corrector made in the UK, huge lenses of 1 meter diameter, the fiber cable, 50-meter long fiber cables with a fantastic efficiency in the UV, positioners made in Michigan, assembled here at LBL. It's been a tremendous amount of work. And also the spectrographs made in France, which have proven to be of excellent quality. And the design is actually used for new projects.
Those new projects, because from what I understand, this decade, we're the first cosmological survey to be online at that level of precision. Do you feel a little bit sorry for the other cosmological surveys that are going to come after us?
I think we've been very lucky to be almost on schedule. I mean, we lost 8 months because of the pandemic. But in fact, during that period, it was amazing how people stay mobilized. For instance, here at LBL, we tested new methods for spare petals to just improve the way we are using those positioners. And thanks to that, we have lost, in fact, little time. It's just about 1 year delay compared to where we think we would have been in 2019. And what's, I think, the most impressive is that in terms of the instrument capability, its requirements, we are just right where we think we would go.
That's very impressive. 10 years down the line, you're exactly where you wanted to be. That's a huge
I think it's fair to say. I mean, plus minus 1 year. But if you compare to other projects, I wouldn't cite them. But in general, there are much more delays. But arguably, it was part of the design to use an existing telescope. So that's a huge gain of cost and time. And also, we are not in space, for instance, where it's another set of issues.
Something I heard a lot being part of the collaboration is that the different leadership roles are filled with skilled people, but what makes DESI particular is that it's the right combination of skilled people working together. Being at the helm of the ship, how do you put together an international collaboration, so different many levels of expertise and people to work efficiently together with such a good climate within the collaboration?
Well, it's a very exciting project, and I think you're here and Julien's here, and we're here because we're excited by the science. And so when you have a great scientific goal, of course, dedicated people will want to join the project and dedicate themselves to it. I've been here for a long time at this laboratory, and so I've developed a lot of partnerships across the world and here at this laboratory. And so, I could pick up the phone and call people, and or they would call, and so it was a lot of fun. I mean, it's a party in some sense. We've been doing I've done lots of experiments in my career, and so there's a certain rhythm to them, and the way that we can form these collaborations, and so that's been great. And have people taken ownership of their of the things that they've been associated with, and I think that's been just great to see that in this partnership.
And what is your favorite memory of the history of DESI, if you had to pick one?
Oh, well, my favorite my favorite moment was when all these components had finally come together, been assembled up at Kitt Peak, and the optics were ready to be tested. And they had quite a history. These optics, they're very hard to make. We had one piece of glass that was in polishing for 3 years. So it was actually a scary moment when all this optics was finally going to be tested. We didn't know whether they, of course, we did everything we could to make sure that they would work. But there's some other very famous projects with optics that didn't focus. And so we were very concerned, well, are these 6 big lenses, been assembled correctly, and have they been polished correctly, and are they going to focus to a little tiny spot? And the very first night that we went on Sky, we had one of those magical moments when the atmosphere was dark and still, and you get the best possible seeing from looking up in the heavens. And right then and there, we qualified our optics in the first 10 minutes of running. So it was incredible. So that was my favorite moment.
Is there a science result that you're secretly hoping, or not so secretly hoping, that DESI will get?
Well, I've been working in cosmology and measuring the expansion of the universe for many years now. So we had this discovery of acceleration with supernovae in 1998, 1999. And we came immediately with this simple model with a cosmological constant, which is actually still totally valid today. I mean, there are hints of maybe some disagreements on H naught, maybe on the amount of clustering at small scales. But generally, we have this cosmological model that is fitting perfectly well the data. Problem is that it doesn't answer any question. So we really hope that DESI, that will make a much more precise measurement, will find a hint of something that would guide us to a better understanding of this acceleration.
Do you reckon there is enough work for many more students to join us now and people to jump on also using those data?
Well, first, the objective is extremely ambitious. We want to measure distances to a precision of 0.3%, which is when you go below the 1% level, that's why you have a huge amount of problems that are arising. So we need exquisite simulations and understanding of the clustering also at small scales, and that requires a lot of brains, basically, for the modeling of the clustering, but also correcting all of the instrumental effects. So that's huge. Plus, just like SDSS was, DESI is going to provide a huge amount of spectra that can be used for many other science topics. So, for instance, looking at redshifts of strong lenses, looking for transient objects, doing hopefully follow-up of some of the very weird stars that are exploding in the universe. So there is really definitely work for many, many people in this big collaboration.
Any management advice for the next big Department of Energy cosmological survey?
Well, think big, start early, and be really young.
I'm extremely excited to see what's going to come of DESI. And like you mentioned, there will be work for years with all the data that we're collecting. Thank you so much for helping and being a big part of making that happen. And thank you for joining us for this interview.